Let's talk in numbers today. Physics. Let's do a work energy problem that involves a block sliding down a frictionless incline. We're simply going to calculate the speed of the block at the bottom of the incline using the energy conservation principle. Before we dive into this problem, here are a few things which we really need to understand. First is what we call the kinetic energy, which is being denoted by Ke, and we also have the potential energy, Pe. So when we said kinetic energy, it's simply the energy an object has when it is moving in motion. Here, let's assume we have an object that weighs, let's say, 5 kilograms. When this object starts moving in motion, the energy it has is what we refer to the kinetic energy. And when we say potential energy, it's simply the energy stored in an object due to height. Let's assume we have a height from the ground, above the ground, let's say is 10 meters. And we have an object on top of that height, maybe, let's say the object have another 10 kilograms. This is what we simply refer to the potential energy. You need to understand that, the kinetic energy is being denoted by formula half mv square. And the potential energy has a formula of mgh. The m here simply stands for the mass, and the v here simply stands for the speed of an object. What about this? Here we have m, which is the same thing, which simply stands for the mass of the object. And g, this simply stands for acceleration due to gravity, which is usually 9.8 meters per second. And this simply stands for the height. If we are to replace our values here, the m, we are going to replace it with 5. And the speed is still unknown. Let's assume it's 20 meters per second, which we are going to replace it with v. And in this case, acceleration due to gravity is normally constant, which is 9.8 meters per second. And the h is simply going to be 10 meters. What about the mass? The mass is simply going to be 10 kilograms. So you need to understand that conservation of energy is the key idea to this problem. It tells us the total energy. And when we talk about the total energy, we are simply referring to the kinetic energy. It tells us the total energy stays the same if there is no friction. So the energy the block has at the top, which is the potential energy, turns into the energy it has at the bottom, which is now the kinetic energy. So let's solve this together. So at this point, what you need to understand is that, let's say you have a block that weighs 5 kilograms. I'm reading from this scenario. Let's say you have a block that weighs 5 kilograms sitting at the top of an incline, which is a ramp that is 10 meter height. And notice that the incline is frictionless, meaning that there is no friction slowing the block down. And the angle of the incline is 30 degrees. So you release the block from the rest, and you want to figure out how fast the block is when it reaches the bottom. Let's solve this by using a diagram. This is going to be 30 degrees. And we said the height is simply going to be 10 meters. So first thing you need to do is to understand that the block is not moving. And we have the block at this point. And remember the word frictionless, meaning that the block is not moving at all. So the potential energy happens due to the height, if you could remember, due to the height. And notice that the block is at the ground level, so all the potential energy is simply going to turn into the kinetic energy. Right? And this literally happens as it moves faster and faster. Since there is no friction, the total energy stays the same. That is why we say the potential energy at the top equal to the kinetic energy at the bottom. So at this point, next thing you need to do is to calculate the potential energy at the top. For you to calculate the potential energy, remember, this is going to be at the top. You are going to be using this formula, which is mgh. And if you notice from this statement, our mass is given to be 5 kilograms. What about acceleration due to gravity, which is usually 9.8 meters per second? And here we're given the height, which is 10 meters. So the potential energy, which is this, is simply going to be potential energy at the top is going to be 5 multiplied by 9 multiplied by 10. If you 5 multiplied by 9.8 instead. It's going to be 5 multiplied by 9.8. You also multiply everything by 10. If you punch on your calculator, it's simply going to be 490. Remember to put the unit. It's calculated in joules. So the block starts with what? You can conclude and say the block starts with 490 potential energy. So next thing you're going to do at this point is to calculate the kinetic energy. But remember, strictly, the kinetic energy has to be at the bottom. Right? So at the bottom, the block has no potential energy because it is at the ground level. So all of the 490 energy is now equals to the kinetic energy. The formula for kinetic energy, if you could remember, we said is going to be a half mv squared. So we can erase everything and calculate for the kinetic energy this time around. Remember to put your 490 joules aside. So at this point, we are going to be focusing on the kinetic energy, which we said is going to be a half mv squared. Kinetic energy, we said is 490. Here is going to be 490 equal to a half mv squared. So, and we said our mass is 5, but we don't know the speed. This is what we're going to be focusing on. So 490 equal to a half multiplied by 5 multiplied by v squared. 490, a half multiplied by 5 is simply going to be 2.5 multiplied by v squared. So we can simply make the v squared to be the subject of the formula. Right? No, but to make it easier, we can choose to divide both sides by 2.5, which is going to be 2.5 into bracket of 490, which is equal to 2.5 multiplied by v squared multiplied by 2.5. 2.5 will cancel out. You're going to be left with making the v squared to be the subject of the formula, which is going to be 2.5 multiplied by 490. So you can simply take the square root at this point, making the v square. So before the square root first, v square is simply going to be 490 divided by 2.5. Then you take the square root. So your v is simply going to be, if you divide this, you're going to end up with 196. Square root of 196 is going to be 14 meters per second. At this point, we can simply conclude and say the block will move at 14 meters per second when it reaches the bottom of the incline. So this is it for this problem. I hope you find it very helpful. If you do, please don't forget to click on the subscribe button. Thank you.